Okay, hold on, I gotta get it readjusted. But anyways, okay, so if y'all, what I'm asking for though is if you could help me out, and if you see it like in another room, since I'm in a lot of rooms, but I'm not in all of them, either of them, if you could please give them back to me, I'd really appreciate it. It would make my life a lot easier. And Miss Leon's, because we both use it. We found it back and forth. Okay. Okay. So let's talk. We got a lot to get through today because I'm gonna still try to cram in some of the CA review. Then we need to wrap up a few things with law of sines since yesterday was a short day. Then we need to go into law of cosines. Now I don't want to take a lot of time talking about this, especially if y'all are gonna just be like looking at your unit circle and not listening. So I'm gonna ask you. I think Unit 3 was a unit that a lot of people struggled with, and we need some recap on that. We won't have time to do all of it next week. So I'm going to ask you to pause on studying your unit circle and listen in with me on this problem, and then we'll come back to that, okay? All right, so when you see a problem like this, if you were looking at it and you were like, shoot, I was not sure where to start, let's kind of think about it and see what we can come up with. So we want to find K. But if you notice right now, we've got like x as well. So we got like multiple variables, which must mean that if we're solving for k, then we have to plug in some value for x, right? Because we can only have one unknown if we're solving, right? And that's why they give us a point. What does this point represent? What does -1 and 4 represent? Tim?
Your x and your y.
An x and a y. So that means I can plug in -1 to my x. And then I don't see y here, but what's y? Adrian? F of x is y. So I basically have y, which we know is 4, equals 5 times e to the k times -1 minus 3, like that, right? Okay, now if we look, we want to solve for k, and k is up in the exponent. So in Unit 3, we talked about how to solve exponential equations where our variable is like stuck up top in the exponent, and somehow we have to get it down. Does anyone remember like overall what we did to both sides to solve this problem of like having our exponent, our variable stuck up there? Yep. We're going to be able to move it, but first we have to do something. You can't just move it right now with e. You can only do that with what? With a log. And so we have to take the natural log, the ln of both sides, and remember that's going to like cancel and stuff, and that'll be nice, and then we'll just have our k regular, not stuck in the exponent, okay? Now before we do that, we would need it to look like this or something before I do the ln. I have to move everything else out of the way. So how do I get rid of the 3? Just, you can just shut it up. Just add it over, and we're going to have 7, right, if I add 3 over here, equals 5 times e to the negative k. I'm going to write that as negative k, -1 times k. All right, and we got to move the 5 out of the way, so divide by 5. 7/5 equals e to the negative k. Now I can take the ln of both sides, and I have ln of 7/5 equals, what happens with ln and e? And we end up with negative k. So what do you think a lot of people are going to start? D, don't fall for it. We don't have k yet. We have negative k. I know it's tempting. You're like, I see it. Anyone circle it already? Yes, everyone. Okay, don't circle it. That's negative k. So we have to divide over our negative, and we have negative ln of 7/5 equals k. But that answer is not there. So, what's wrong? Does anyone see one that they think might be our answer, even if you don't remember exactly why, or what are you maybe thinking could be the right answer? Isaac?
I think it might be e.
E, do you know why?
Because if you carry the -1 as an exponent, it just inverts the...
Okay, so remember, anything in front of an ln, like 2 ln of x, you can write as ln of x squared. You can bring something that's multiplied in front is the same thing as an exponent. So this is like having ln of 7/5 to the -1 power if I bring the negative as an exponent, and a negative power we've talked about how like 2 to the negative 1 is 1/2, it sends it to the bottom, right? And so if I have 7/5 to the negative 1 power, that's gonna become 5/7. A negative 1 power is gonna flip it like that, okay? Which means our answer would be E. Cool? Okay, so tonight, we're gonna try that out. I have another problem, because maybe you guys, if y'all don't mind putting that away for right now, that'd be great. If you were like, shoot, I didn't remember that you have to take the element of both sides, I want you to take the time tonight and try solving this one. It asks you when the population equals 8,000, which means you're just gonna set it equal to 8,000 and then solve just like we did, so try that out. And bring your questions tomorrow. If you don't know how to solve it, then please come with questions, but I'm asking for 3 minutes of your time to try this out. Did anyone try the one from last night?
Yes.
Looks like this. While I'm passing this out, any takers think they know what this is, so we can check it for anyone that took advantage of this one? Mon, what do you think?
Yes.
Let's take a look. H.
I guess
Anyone else think H?
they.
Jimmy, Jeannie? Cool. Yeah, if you take a look at H, H has roots at 0 because of the X in front, at -3, and at +5. And then A is less than 0, which means it's negative, and that's why it's facing down the end behavior on both sides. Cool? Okay, so that one would be H. I'm gonna keep us moving for the sake of time. So we're gonna go ahead. Last time for our unit circle to practice for your quiz tomorrow and your unit test Tuesday, where you will not have your yellow unit circle with you. You're gonna be doing all 4 quadrants. So I need all yellow sheets away, all the ones that I passed back to you away, since it has a lot on there. All of those things.
Ready.
do if you're done is we're gonna start, checking them here, kinda like we did yesterday. So if you finish, then put your pencil away and I can either give you a pen or grab your own. And you can start checking it on your own, but I shouldn't see your unit circle out and you checking until I see your pencil away, just to make sure we can't change anything. Once you decide it's your final answer for everything, then grab your unit circle and check it for me. Anyone else need one? About 30 more seconds. If you haven't already finished, to finalize your answers. And then go ahead and put the pencils away. Grab a different color pen or marker if you need one right here, and I'll come get you. And everyone should be checked in. And then write how many minus however many. And then let me know when you're done, I'll come get it. If you have turned it into me, if you can go ahead and just get your notes out so that we'll be ready to go and we can make up for some lost time, that would be great. So quickly. Grab your notes if I grabbed your unit circle already, just so we can get started ASAP. I'll grab your notes. Okay, give me a second. I'm just gonna start kind of taking them, and I'm gonna check the rest of it. Alrighty. So on your notes, let's get started with. Let's get started with wrapping up law signs and going on to law of cosines. All right. Just a reminder, are there any out there I missed? Okay. Don't forget about your problem set that's due on Monday. That's going to be a lot of good practice for this quiz and unit test. Like, for example, there's a whole section that's very similar to the basic skills of your last quiz and this upcoming quiz and test that has a bunch of those, just like sine of 3 pi over 4 and random things that now you won't have the yellow sheet of paper, so you can practice doing without the unit circle in front of you. So it literally says in the directions like, stop, don't look at your unit circle, try these out. So I would recommend trying a few of those before you come in here, because it is a little bit different of a skill of thinking of one in isolation rather than like writing the whole thing. And I don't think you're gonna have time to draw the whole unit circle like before you start. I don't recommend doing that, okay? Your unit exam is Tuesday, and then next week, just to have on your radar, as we start our common assessment review, I need you to be bringing your calculator. I know sometimes we like borrow from a friend because they don't have math class the time you do, but when you take your common assessment 2 Mondays from now, the whole school is going to be doing math common assessments at the same time, which means you need your own calculator, and you need your own calculator to be in the right settings, and we're going to be setting that in class next week. So for example, I'm going to be having y'all walk through on Thursday, the last day, how to put it in press to test mode, and I know some people might know how to put it in press to test, but there's actually some things that you can check off or not, and I need to make sure that y'all don't accidentally have checked off that you can't use trig functions, because I don't want you to get in the test and like not be able to use sine and cosine and things like that, right? So there's lots of different settings we're going to be setting, and I want to be setting on your calculator so that you're not stuck in a weird situation on your test, all right? So as a heads up, please be making sure you're finding your own calculator and bringing that. All right, so yesterday we talked about that problem with the satellite. Okay, so we introduced law of sines, and we set up and we found the distances, I think, from at least one of the laboratories to the satellite. Now I want to talk really quickly just to recap law of sines on problem 1 right here, and then we're going to talk about kind of a special case with law of sines, and then talk about law of cosines. So let's talk about law of sines. Yesterday we learned that law of sines is when we take the sine of an angle and we divide it by the side that's across from it. That should be equal to any other pair of angles and sides, right? So if you take a look at this triangle, can anyone remind me what would you maybe find first if we need to find angle T, side S, and side T? Those are all missing values. What do you think, Cristobal?
Angle 2.
First, just find angle T. Probably knock that out, add up 63 and 51, and then subtract from 180. So go ahead and find angle T for me right now, super quick, right off the bat. Find angle T for me. Raise your hand when you got it, just so I can see. I'll wait till I've got like 10 hands, 10 people that got it. Who's got it? Justin, Jason. Got it. Got 2 people, 3 people, 4 people, 5, 6, 7, 8. A couple more. 9, 10. Edlin, what'd you get? 66. Y'all got that? Okay, cool. So knock that out. We got 66 degrees for angle T. Now, when I'm using law of sines, I need sine of A over A, or sine of B over B, or sine of C over C. Does anyone see a pair where we have the angle and the side that would go together? Where we would have both pieces of our ratio. Brenda? R. We have the angle and the side, right? So let's use sine of 63 over 13. We're going to set that equal to, and then pick whichever one you want. Which one y'all want to do? T. I heard someone say T. If I want to find T, then I'm going to use sine of 66 over T. Right? Then we can cross multiply and we can solve. So if I cross multiply, we'll have T times sine of 63 equals 13 times sine of 66. The last step, how can I get T by itself? Adrian? Good. And then we just make sure that we're in 2 degrees, and we plug that whole thing into our calculator. So go ahead and plug that in and see what you get. 13 times sine of 66 divided by sine of 63. Any takers? So what'd you get? Three of them. Yeah. And this says round to the nearest 10. So if they ask specifically for that, then I would like round right here at 13.3. But I'm going to still write the whole thing because I don't want to confuse y'all. We typically pre-cal still go always 3 decimal places. So expect to see that more on a unit exam. This is kind of a weird example where they asked you to 10. Yep.
So whenever we try to find like we were trying to find like a side of an
Yeah, we're trying to just generally solve the triangle, which means a triangle has 3 sides and 3 angles. We want to know all the pieces. And we knew one side, so we needed to solve for T and S. And we knew 2 of the angles, so we needed to solve for this angle right here. So we already got one of the angles, 66. So now we have all the angles. Now we have this side and we have T. So the only thing we have left is now we need to find S. We want to find everything. For if we're using law of sines, yes, which is the rule where we're dividing like this. In a second, we're going to use law of cosines, which does not mean the exact same thing with cosine. It's like a different equation. Okay? Cool. All right. So now, last up, before we move on, if y'all can try to show me that you feel good about this, solve for side S for me so that I can make sure that you know how to set it up and solve. So I'm going to walk around. That's okay. You can still set up the sign of whatever or whatever. I want you to show me what would you set up now to solve for side S. Pick someone to tell me the ratio. Everyone should be writing down the ratio they're going to use to solve for sine S. Ryan, can you tell me what like ratio you use for S? Cool. Equals, and then if we want to find S, which angle do we have to use? Which angle goes with S? Which one? Look at side S, and then we're looking at across from it. Which angle goes with S? Here's S. Which angle goes with S? 51, so we're going to say sine of 51 over S. That's what we should be solving when we do our cross multiplication. Yep.
What can I use sine of 66?
If you use 66, then you're going to be solving for T again, because 66 and T go together.
For like sine of, so like whenever you said sine of 63.
Oh, you totally could. Yep, he just used this one. So this is what did you say, 51? You could also use sine of 66 over 13.328, now that we have it, equals sine of 51 over S, and you should get the same thing.
Oh.
So pick whichever one you like, okay? And for S, you should get 11.3 something? Yep, cool. All right, so I'm going to move on from this. So that was yesterday what we did when we have, if you notice, for a law of sines, notice in all these examples, we either had an angle, another angle, and a side, or if you look at this example right here, you have an angle, a side, and an angle. So all of those examples we've used so far, we've at least had 2 angles, right? Like an angle, and a side, or an angle, a side, and an angle. Okay, just depending on the order. If you look in the study guide in the red folder, so I have in the red folder, if you haven't already grabbed it, the Unit 4 study guide for your quiz and your test. Law of sines is on the back, and I said, use this when you have angle, side, angle, 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 side, or the other case that we haven't seen yet that I want to talk about now is when you have two sides and one angle. When you have two sides and one angle. So, the only thing that you have to be careful of with two sides and one angle is that this is something that we call the ambiguous case. Now, we're not going to see this a whole lot, and I wish I could spend a whole class kind of finishing off law of sines, but realistically, we got a lot to get through still with our unit exam and like quiz coming up, and I want to prioritize making sure I get to law of cosines, okay? So, I'm not going to talk a whole lot about the ambiguous case, other than the fact that what happens when I give you two sides and an angle is that technically any two side lengths, depending on the angle, I might run into some issues where, like, if one of the side lengths is too small, it might not even be possible to form a triangle. Like, it won't reach across to the other side, which means you could have no solution. Okay, another thing that could happen is depending on the size of the two sides, I could make a triangle that looks two different ways with two different angles. And so there could be actually more than one solution. Okay, so we have to be careful with this like small case, already within a small case of doing law of sines problems, where we have to technically, I wanted to at least expose y'all to this, check a few cases to figure out like how many solutions we would even be looking for, okay? Now I'm going to do an example where we have just like one normal solution, because that's what we're going to see most of the time is just a normal triangle where they're going to give you one that has a solution and you find the solution, just so we can practice like working backwards to solve for angles, because notice here we're going to have two missing angles that we have to solve for, okay? So let's take a look at this next triangle. Now you have to pay attention to whether the angle is acute or obtuse. So if you look at this triangle right here, the angle that they gave us, is it acute or obtuse? Obtuse. So if you take a look right here, we either need to make sure there's either not a triangle that's possible if A is less than or equal to B, but if A is, as long as A is greater than B, then we will have one solution. And like I said, that's what's going to happen like most of the time that y'all are going to see for realistic purposes. So if you take a look right here, 15 is bigger than 12, so it like physically can reach across the triangle, reach across that 94 degrees. So I'm going to go ahead and tell y'all that if you check all the rules and everything, you are going to be good to go with this triangle. There's going to be one solution. So we can use law of sines and find that one solution. Okay? So let's take a look. If I set up law of sines, what pair of angle and sides, Cleo, do we know? What can we start off with? Angle A and side A, right? We got 94 degrees and across from it we've got a side. So let's say sine of 94 degrees over 15 equals, now this one I can't really just pick either one. Which one am I going to have to find first of my angles? Brenda? C, because I've got 12. So I can say sine of C over 12 like this, right? Cool. So let's find angle C. We haven't solved for an angle yet. We've only solved for the sides. So I wanted to make sure I model one of these. So let's do cross multiplication. Make sure you're still with me. Cross multiply 12 times sine of 94 degrees equals 15 times sine of C. Divide by 15 to move that over. 12 times sine of 94 divided by 15 will be equal to the sine of C. Now this is interesting because C is like stuck inside of sine, right? It's not, we haven't solved for C yet. It's over here. Is C an angle, this big C? Is it an angle or is it a side? Remember, we're solving for an angle, so good thing, because on Monday we learned about how to work backwards whenever we want to find an angle. When we have like the answer, we have like the output and we want to find the input. What do we do to like switch those and solve for this? I heard a couple of people. The inverse, right, is how we solve for the angle. We can switch it. So remember we said that I basically switch x and y, or I switch my input and output, and I can rewrite it as inverse sine of this will equal C. right? Like I can switch them. So I'm gonna switch and I'm gonna put C over here, and on this side I'm gonna put my crazy 12 times sine of 94 over 15, but I would have to take the inverse sine of all of that stuff to find C. So what you're gonna plug into your calculator when you're solving for an angle is gonna be the inverse sine of all of this stuff, okay? So go ahead, grab your calculator, plug that in and make sure one more time that your calculator's got all the right settings and everything good to go. Let's see what angle C is equal to. And it does say here round to the nearest degree. Again, we gotta be careful. If it doesn't clarify, we always go 3 decimal places. But you end up getting 53.999 or 52.999. Which one is it? Okay, so it ends up rounding to 53 degrees roughly. Now that we have that, we're back to a triangle where like anything goes. We can add up and subtract from 180 just like we did before. And you'll find 33, so same thing, Jason, we want to find anything that's missing. So you can go and find that last angle, and then we could use the law of sines to go and find that last side like we just did, right? Okay, so I'm going to leave you all to try law of sines to solve that last side B, and I'm going to have us now talk about the law of cosines for our last 10 minutes, all right? So, flip one page over to page 29. Flip to page 29, and let's take a look. So we've got, on page 29, a problem that looks like this. It has a side of 8, and then an angle of 65, and then a side of 5. Notice we've got a side, an angle, and a side, SAS, which I don't see in this list here, so this is something new. And let's see what happens when I try to do law of sines. So let's pretend we're like, oh, it's a non-right triangle. I know I can use law of sines. We go to try it out. And does anyone see an issue when you try to set up law of sines? Jason?
You have to find the angle.
Yeah, okay, so we gotta find an angle. So I'm like, okay, maybe I'm gonna try sine of A. So I'm gonna find A, the angle, and I know I've got 5 right here across from it. But what happens that gives us some trouble, Isaiah?
You don't, like, you don't have a ratio to use from that?
Yeah, I don't have a ratio where I have the angle and the side. So like if I come over here and say sine of 65, now I don't have C. See how I have like 2 unknowns? So no matter like what combination you try, we run into issues with law of sines whenever we have an angle, side, angle. But it doesn't mean we can't solve the triangle. There's actually something else we can use. It's called law of cosines. So on your study guide, you'll see law of cosines. I say to use when we have angle, side, angle. Or also if you have all 3 sides, side, 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 you can tell like you would have 2 unknown angles, so that wouldn't work either, right? Okay. But like, don't worry about remembering this so much because just like this one, if you set it up, it wouldn't work. And so you'd be like, oh, I'm stuck. I'll have to use law of cosines. Okay? Law of cosines is 3 possible equations for the 3 different sides of the triangle. And we're going to be talking about the same A, B, and C, where A, B, and C, the angles are across from the sides A, B, and C, right? Okay, so same triangle. Let's take a look a little closer at this equation. These look kind of like crazy complicated equations, but if you look closely, you'll just see the pattern and kind of be able to write it down for whichever one you need. So if you're talking about side A, take a look right here. Side A squared, if you look at all these equations, they have the same kind of template. The cosine, the angle that's inside the cosine always matches whatever side is over here. See how if this is side A, it's cosine of A. If it's side B, we're taking cosine of B. If it's side C, we're taking cosine of C, okay? So we know those are like on opposite side of our equations. On the inside, we have whatever the other 2 sides are. So if we're solving for A, then I'm going to square B and C. and I'm gonna subtract 2 times b times c. So notice in here are all the like other sides that we don't have. Alright, so let's take a look if we can use that to set us up with some numbers on an actual problem. Let's do the same problem we just looked at. It's on the next page as the first practice problem. It's the same one we just looked at that we said we can't use law of sines. Let's try to use law of cosines. Alright, so I see right here that I have this angle. I'm going to have to find my other 2 angles and one side. So if I have that angle, that's going to be my starting point, which means if you look at law of cosines, and I have cosine at the very end of the equation, I have cosine of an angle. If I use 65, because that's the only angle I have, on the other side of my equation, there's going to be all this stuff right here, but on the other side of my equation, what would I have to put over here? Which one goes with 65? 65 goes with c. So this is going to have to be c squared, right? See how you kind of like figure it out based off of, okay. And then I said the other 2 are what goes here, right? So if this is c, then I'm going to put 8 and 5 over here. So I'm going to say 5 squared plus 8 squared minus 2 times 5 times 8. So same pattern every time, just the other 2 sides squared minus 2 times the other 2 sides times cosine of the angle that goes with c over here. If you look at the equation, actually I'll put it up here. They're all squared. Okay, we're just plugging it in. We just gotta plug it in the right places. And then if I want to find c, I just have to take the square root. So I'm about to grab my calculator, but I'm just going to take the square root before I grab my calculator. Now grab your calculator, type in the square root of 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 65. Then it's just a matter of using like your calculator to do the rest of the work. And we get c equals, any takers? Adrian, over to you again. 9, maybe? You round it, maybe? Okay. Alright, so now we've got this side. The nice thing about, like, a lot of times when you have law of cosines is you don't have to necessarily now use law of cosines the rest of the time. If you want to use law of cosines to find now something else in your triangle, you can. But do I have enough information now to go back to law of sines?
Yes.
So now I'll let y'all go ahead and like finish this off for the rest of the period. You could say sine of 65 over 7.429 equals, and then set up a ratio for the other 2 angles and use the inverse to solve, okay? So I'll let you keep working on that. I'm going to set up the first one just so you can see what, like if you want to find 8, you could use that. If you want to find A, you could use that, okay? So see if you can cross multiply and then take the inverse in our last 3 minutes, then we'll check it before we leave. And then we'll get to review some more of this on Monday if y'all still have some questions about log cosine since we didn't have as much time. Okay, so that's what you did. Alright, y'all, eyes up here, you got one more minute, don't pack up yet. We got one more minute. For these are gonna be the ones where you're solving for an angle that what you put in your calculator should have been an inverse sine, right? An inverse sine of something. So you should end up with, roughly, if you round to the nearest degree, 38 degrees and 77 degrees. 38 degrees and 77 degrees. Okay? Alright, stack your chairs tomorrow, we got a quiz.